Thanks for the introduction. This is going to be a bit statistics heavy. For example, right? So dispatch algorithm. So what I was giving example before is an user or driver faced feature, but we also test, or all companies test some internal features, like at an algorithm level. And this is actually a good example of where machine learning and hypothesis testing is being used simultaneously, right? So the dispatch algorithm, ETA prediction, estimated time of arrival, that's a machine learning algorithm. However, we want to know, some subtlety, like, we have seen that, if instead of giving an exact point, if we say, the point of the pickup point is some corner of the street, that probably helps both driver and rider, in terms of, so there is that element which cannot be predicted by machine learning, but we can test the hypothesis by, changing the algorithm, right? So, okay, so now, what is experimentation? Basically, so this is, how the scientific method has worked for the last 400 years. And, it's, you define a question, you gather information, form hypothesis, right? This is how all of the science, not just industry, has worked. And if you look at this circle, about, more than 50% of this is about, defining the hypothesis and, basically doing something with it. So the simplest way to test hypothesis, as I was mentioning, is to do A/B testing. So what is A/B testing? A/B testing is by far the simplest form of testing the hypothesis. Imagine you have, we just call it A/B, but basically you can have, multiple groups. So it doesn't have to be just two groups. So you have multiple, groups. And you have you have an incoming traffic. Let's say in this figure you have 50% visitors to your website that are seeing some variation, right? So in this case, it's the color of the one of the tab has changed from red to green. So you randomly split your visitors, and you show the red tab. You also show the green tab, and you try to see, maybe that tab is, buy something, right? So you want to see, in this case, how much conversion you are seeing. So maybe the green tab shows 11% conversion, the red shows 23%. And, so you can hypothesize that, okay, I changed that color of the tab, and that led to a increase in the conversion rate. So that's the very simplest form of hypothesis testing. Of course, it could be that during the time you were testing this, you have also introduced a buy one, get one promo, and your marketing department did not know that this has been introduced by another department. So, it is quite possible that the same cohort of users are being bombarded by, these two separate features, and they are interacting. So this is the collision effect that I was mentioning. And there is no way to sort of control unless, you really control. You cannot have full control on the users, basically, right? So you can, maybe select, okay, one city will get, feature A, and another city will get feature B, and, try to avoid the collision effect by that. But yeah, it's there. It's one of the real world messy problem that we deal with every day. But in spite of that, we can draw some conclusion. In this case, maybe the red versus green has improved the conversion. So fun facts about, A/B testing in recorded history. So I was searching, who was the first guy who did it? Probably he did it. Obviously, it was not named A/B testing back then. So this gentleman, he was a British Navy captain, or actually doctor. In the 18th century. And so scurvy was an epidemic back then. And sailors used to die. So what his hypothesis was, scurvy could be cured by some acidic component in the food. So what he did is he divided 12 sailors into 6 groups of 2. and gave everyone the same diet, and he added some variants to the diet. And at the end of the experiment, group 5 who received oranges and lemon, which had some vitamin C, have recovered within a week. And I don't know the outcome of the rest of the group, but they did not recover, I think. But yeah, this is one of the earliest example of A/B testing. Was he absolutely sure that this was only giving oranges will cure scurvy? Maybe not. But this gave him some idea that this is the right direction, and he basically formed a hypothesis and that concluded based on this experiment. Yeah. So in today's day and age, we definitely don't experiment with only 12 data points. We have a lot of data. So the basic flow of the experiment really hasn't changed in the last 200 years. We still form a hypothesis, and we ask, well, how much lift we desire.
What do you mean by lift? What do you mean by lift?
Lift is
Not a company to Uber.
no. Oh no, it's not. It's not LYFT. It's LIFT. That's a good one. Yeah, I made sure I did not make a spelling mistake there. Yeah.
So the question is, it's not exactly A/B test, it's A to N test, right? I mean, you are trying many factors.
Yes. Yes.
At a time we may cover comparing 1 and 1, but essentially you're doing 1 to N.
Yeah. Absolutely.
What do you mean by that? What do you mean by that?
What is meant by lift? Yeah, so lift is, remember I showed that conversion in the previous slide. Yeah, this one. So in this case, the lift is 23% minus 11% divided by 11%. So how much change I'm seeing between the two variants? Right, so I will get to type 1, type 2 error in next slide, but basically those are the two sort of safety factors, or the how much tolerance to errors we can have while determining the lift. So we decide that first, and then basically the business decide, okay, we want, for this feature we want 10% lift, or else it's not worth rolling out the feature, right? And then we need to understand how many sample size or how many people or users should see that feature. And then the rest is split the data into two groups that I was showing in the previous slide, and we expose treatment to one of the groups, like that British Navy captain did, and you basically see you wait until the required sample size is attained, and after that you see what the difference in the lift is. So that's the sort of the flow chart of any experiment conducted in any company. So that doesn't change by much. Now, what is the type 1, type 2 error? Type 1, type 2 error, so imagine there is this box, and so we are basically, this is the measured, and that's the reality. And we are measuring this, and we want to be in these diagonal boxes. So being on the diagonal boxes are good, which means we are correctly predicting someone will click on a feature or will not click on a feature. They're both equally good. Even if I can predict correctly that someone won't click, we won't show it to that person. We don't want to be in these two boxes, and they are the type 1 and the type 2 error. So type 1 error is when the reality is false, but you predicted true, so that's bad. And equally bad is, when the measurement says false, but the reality is true. So that's a missed opportunity, basically. But in real world experiment, it cannot be perfect. So we have to have some tolerance to that. Like we are okay with 95% type 1 error. 5% type 1 error, 95% correct. And for the type 2 error, we are okay with 80% correct and 20% error. So that's sort of the rough ballpark that industry typically just use it. But we can use any number we like. So, and here is one example, right? So your hypothesis in this case is we introduce a new feature that will increase the CTR, or the click-through rate, like I was showing a couple of slides back. And then the business typically would decide, how much increase in CTR they actually want. So it's not just about increase versus not, right? Sometimes maybe introduction of that feature, let's say buy one get one offer, that actually cost money to the company. So introducing a new feature has to have a quantifiable increase. So it's not just increase in CTR, it has to be increased by 10% to make it worth it, net cash flow positive. So once we decide on that, and we decide on that we are okay with roughly 5% of false positive and 20% of the type 2 error that I was showing earlier, and then we conduct the experiment. And here is another way to visualize what the type 1, type 2 error is. So this is a null hypothesis. A null hypothesis is you introduce the feature and no one cares. So zero CTR in lift. Non-null, or the alternate hypothesis is, you see a lift of at least 10% or more, right? And this is your type 1 error, like you don't want to be here, and your type 2 error is you don't want to be here. So any mean that you measure that is on the left of this blue curve, somewhere here, is probably acceptable lift by the business. So that's one way to think about type 1, type 2 error. Preference to have less false positive. Why we want to have less false positive? Yeah, basically if you look at this plot, right? So false positive is this quadrangle. And, in reality it is false, and, you are saying true, which means the company is actually bleeding money. Right, exactly. The second one, we are okay with bit more error, so you said 20%. Exactly. So it's a missed opportunity, but it's not costing money. At least we didn't lose money, but we also did not gain much. So 20% error is good, but with that 5% error, you're actually losing money, right?
So
anything more?
Some kind of weight, I guess. So
Yeah, it's like we run experiment with 2% false positive if needed, right? So it's really depend on the sensitivity of the feature and the money involved, and there's a whole business decision that happens before this to make that call.